Welcome to video lectures. Myself Nirupa, Assistant Professor, belongs to CSE Department, MITS. I am here today to give video lecture on Java collections. Today I am going to, today the flow of presentation is like this: Introduction to collections. What is framework? We'll discuss what is framework and advantages. What are the advantages of framework? Hierarchy of this collection framework. List interface. There are many interfaces, but today I'll be discussing about list interface. And some classes belongs to list interface like array list, linked list, and vector. This is my flow of presentation for today video lecture. Coming to the introduction to collections in Java, very important topic in Java. Actually, grouping of objects into a single unit is known as collection of objects. For this, we have separate framework called collection framework, which has been defined in JDK 1.2, which holds all the classes and interfaces in it. Mainly in Java collections, we are using two interfaces. We will discuss in detail about this: collections and map interface. Collection interface is the top interface, uh, which all the interfaces extending this collection interface. This collection interface and map interface belongs to the util package. It belongs to util package. Now coming to this slide, what is framework? Framework is nothing but it is a predefined or ready-made architecture which is used for us. We can use the classes or interfaces available in this framework or already predefined classes and interfaces that can be used in ready-made. And Java collection framework provides many interfaces. We will see in the next slide also, like set, list, queue, dequeue, and classes. Classes like array list, vector, linked list, priority queue, hash set, linked hash set, and tree set. What is the need of separate collection framework? Before collection framework, which was introduced in JDK 1.2, there were some standard methods which are used for grouping of these objects. That methods are like arrays, vectors, and hash tables. But why we are going for this collection framework is these arrays, vectors, or hash tables, they doesn't have any common interface. Since they doesn't have any common interface, they are not correlated to each other. And as well as it is very difficult for the users to remember all the methods, syntaxes, constructors present in each and every collection, each and every classes. And it is difficult for the programmer to write the algorithms by using all these kinds of classes. So they have gone for the collection framework. That too, it is implemented in JDK 1.2. Advantages and hierarchies of collection framework. What are the advantages of collection framework? It gives us like consistent API. It is a consistent API where you will have the classes, all the classes will have the common methods, and it provides this consistent API. And one more advantage is reduces programming effort, reduces programming effort, and it increases the programming speed and quality. How it reduces programming effect as well as how it increases the programming speed and quality is it uses the data structures and algorithms. Quality data structures and algorithms are used, so user or a programmer directly can use those data structures. With the help of those data structures, the programmer can implement very efficiently. Speed and quality is maintained using this collection framework. These are all the main advantages of collection framework. Coming to this hierarchy of the collection framework, in Java, most of the topics are having the hierarchy of the classes. So you can see this if you in next slide we will see the hierarchy of the collection framework. But util package consists of all these predefined classes and interfaces that are required for collection framework. Util package. So coming to the collection interface is having many methods, which these methods are all inherited by all the interfaces or the classes interfaces which uses this collection. So one more interface is there, iterable interface. Iterable interface provides an iterator which helps us to go through all the collections. It acts as an iterator or iterate through all the collections. You can iterate through all the collections. So this interface, this iterable interface is not seen in the hierarchy diagram, but collection interface, which is the top of the hierarchy, actually extends this iterable interface. This interface is extended by the main collection interface. That is the root for the collection framework. All the collections, all the collections extend this collection interface, thereby extending the properties of the iterator. So action, collections is uh, collections is having or implement or sorry collections is extending the iterable interface. So all the all the interfaces whichever is extending the collection interface will have the properties of iterable interface also. Next, coming to this uh, collection framework hierarchy. Here, if you see this diagram, here you are having this pink color as well as this light orange. Pink color represents this classes as well as this light orange represents this interfaces. Here the main interface is collection, which is the root of this hierarchy, and this other interfaces like set, list, queue, dequeue, a sorted set, these are all extending this collection interface. Directly list is extending, set is extending, queue is extending, and again one more interface dq is also the sub interface of this queue interface, and sorted set also is sub interface of this set. Like this map separately we have for the map. Today we will be seeing about this collection, and in this collection interface we have the many methods. Like to add an object we have add method, to remove an object we have a remove method, uh, to find the size of the collection we have the size method. Like that many predefined methods are available in this collection interface. Now today we will discuss collection interface and list. We have seen these interfaces, and coming to the list interface is having again some classes like array list. These are the classes which are implementing this uh, list interface. Those classes are array list, vector, stack, and linked list. Mainly array list, vector, and linked list. Stack is again a subclass of this vector. We'll see one by one this in the next slide. List interface. A list interface, which is the sub interface of the collection interface, that is list interface extends the collection interface. It stores elements in a sequential manner. Elements in the list can be accessed or inserted based on their position. Based on the position, the index position starts from 0 in the list. All the elements are stored in a sequential manner, and list will allow the duplicate elements. This list interface will allow the duplicate elements. And iterator also, just now we have seen that iterator can be used to access the elements present in the list. Here are the classes. Here are the classes array list, linked list, and vector. These are all the classes which is providing implementation to the list interface. Array list, linked list, and vector. Next, iterator. Iterator is an object that enables you to traverse through the collections, can be used to remove elements from the collections. Two operations can be done with the help of the iterator. One is you can traverse through the collections, and another one is you can remove the elements from the collections. If you see here, the interface iterator is having the three methods. The three methods are has next, next, and remove. Has next method is a boolean, it returns a boolean value. With the help of has next, you will be finding whether you have next object or not. Next method is used to get the object, and remove method is used to remove the object present in the collections. These are the three methods available in the interface iterator. Next, this is the code I'll be explaining later while giving the demonstration how to use this iterator with the collection classes. Here in this example, array list is the class we have used, and iterator is used to traverse through the array list. That I'll be explaining during the demonstration. Array list class. Array list class implements the list interface. It supports a dynamic array that can grow dynamically. The size of the array list is increased or decreased automatically based on the adding of objects or removing of the objects into the collections. Generally, standard arrays are of fixed size. They don't dynamically grow in size. After arrays has been created, they cannot grow or shrink. Whereas coming to this array list, which is implementing the list interface, can grow dynamically. That is one of the major advantage of using the array list, and it is very powerful mechanism for insertion as well as search operations that can be done, and it gives faster iteration and fast random access. Ordered collection by index. This is, you can have this ordered collection of objects in this array list, but not sorted. There is no sorting of sorted list you will get from this array list. Array list cannot be used for primitive data types like int, character, etc. What does it mean in the sense? These collections will work on objects. It does not works for primitive data types like int, character, float, all these things. It works for objects. So we have to convert these primitive data types to objects. For that, we can use the wrapper classes. Wrapping takes place, which converts the primitive data types to objects. So int primitive type, you can use integer wrapper class, and for char you can use character wrapper class. Like that, similarly, we can use all the wrapper classes in which the primitive data types are represented in the form of objects. So you have all the predefined wrapper classes. We can use those while using these collections or while using this array list. So this, if you see this, how will you create an array list? You have an array list class, array list, and you have to specify here data type. Data type. Here we have given int. We cannot use int here. We have to use integer. Integer is a wrapper class for integer primitive data type. And we know how to create an object to the class array list. Object name equals to new array list. Now we are creating an object to the array list so that you can add elements to the array list, or you can perform any operations, any manipulations to this array list, add, delete, or sort, or find the size. All these things can be done. Okay, there are some predefined methods. There are some predefined methods available in this array list class. They are, I have not mentioned all the methods. Few important methods I have mentioned here, like add. Add, you can add an object. You can add an element with index. Index also you can specify position where you want to add an element. Suppose 0 if you are giving as an index, and 10 if you are giving as an element. Since I have taken as an integer, I can use the element as 10. Since if you are taking character or some other data type, you have to mention, you have to take the same data type element here. 0th index if you are using, and 10 if you are giving, that 10th element will be inserted in the 0th position. This is one method. And without specifying index, you can add an element, that is add method. Add, and you can give directly the element, so that that element will be added at the end of the list, array list. Add all, another method you have is add all method, where you can add one collection to the other collection. One array list can be added to the other another array list. Get another method is, you have get method, and within the braces, or you have to specify the index. So get method is used to get the object from an array list. Okay, similarly you have a remove method, which is used to remove the object from the collection array list. And size method is there to find the size of an array list. These are all the some few methods available in this array list. Now we will see the demonstration of array list program, and we'll go to the next step. Now we will see demonstration on array list. So for that I am using Eclipse IDE. I'm clicking on Eclipse IDE. I will show right in the beginning. I'm taking Java project. For that, you have to click on the file menu and I have to take new Java project. I'm showing how to do in Eclipse IDE from beginning. The project name I'm giving that collection 500. After that, you have to click next and you have to finish it. Once if you have created this Java project, you can see in the left panel. If you click here, you will get the two things, system library and as well as source. Now I have created the Java project. Next thing you have to do is you have to create the package. Right click on the source and again go to the new, take the uh, take the package. The package name you can give. I'm giving it a collection first. Finish. Click on finish. Now package also has been created. Again right click on this package. Now I'm going to create the class inside the package. Creating the class. I have to give the class name and give it example 1. And I need the main method to be included in this program. So I'm selecting this main method as well. And after that I'm clicking on the finish button. Now you can see here in this area you have the package collection file and the class has been created with main example 1 and main method also has been included here. Now today I told I'll be doing demonstration on array list class. So I will create an object to the array list class by using the array list class. Array list object, and we have to mention the type, data type. So I'm taking integer. Since collections work on objects, we have to use the wrapper classes, not the primitive data type. So I'm using the integer class. Integer class is the wrapper class which wraps primitive type int. I'm taking integer and object name equals to int. We have to create an object using the class name array list and give the data type. An object has been created for the array list class, and we have to import the required package. Import util.class. Util dot. If you want specific class to be included, then you can import java.util.arraylist. Or if you mention it as a star, all the classes will be imported. Belongs to the util package. Now after creating an object to the arraylist class, I am going to perform some operations like adding, removing, all the manipulations I am going to do on ArrayList. First I will start with the adding of elements to the ArrayList. So if you take the here ArrayList name is A, so I am taking it A. I am going to add some elements A dot. If you click A dot in Eclipse IDE, you will get all the methods. These are all the methods available in ArrayList class. Just type A dot. A dot. Here the ArrayList name I have given is A, so I have taken A dot. Once if you give A dot, all the methods you can see here. These are all the methods belongs to ArrayList. So for adding, you can check by pointing the mouse in each and everything so that you will get the explanation of each and every method available here. So mainly two operations I'm going to show now, two manipulations I'm going to show now. For example, to add an element or to add an object to the collection ArrayList, I'm going to use the add method. And the argument need to be passed here is integer object. So I'm taking a dot add some integer input. Here I'm treated as an object. Similarly, I'm going to add some more objects. So now I have done addition of elements to the array list. Next we can do, you can access the elements present in the array list. There are two ways to access the elements present in the list. I will show one by one. First I'm taking one statement to display the array list. The array list is here. So with this I'm executing this and running this Java program. Just adding the you can see here these elements are in the form of list. Another way you can access the array elements is by using the get method. You can use a dot get method. Get method is used to access the element present in the array list. I am taking a dot get within the braces. I am going to give the index. So I am giving here 0. So after that, just I am taking only one element to be displayed. So I am trying to execute and show you the output. So see here, you will get only 10. The first element which is located in the 0th index will be present. So whichever index you want, suppose you want 1, you can, suppose you can use second index, you will get that particular element. Get method also you can use to get the elements. So this is one way of getting one element. Next, you can traverse the elements present in the array list either by using for loop you can take, or you can use the iterator. So first I'll show by taking the enhanced for loop. For that we need a syntax for and using the for loop. Variable to traverse column and I'm giving the array list name. Here is the array list. So here I'm going to display. And I'm going to display I. Okay. So just I'm using the list variable I so that every element will be traversed in the array list. If you run this, you will get the elements. You can see the elements 10, 20, 30. You can see the elements. This is one way of traversing the array list. Enhanced for loop or normal for loop also we can use, where index is taken as a priority for displaying the elements. Next, another way of traversing an element in an array list collection by using the iterator. I'm going to create an object of iterator. I'm going to use this iterator to array list. So I'm using array list here is u. So I'm using this method in iterator. Okay. Now I already seen there are 3 methods: hash next, and remove methods are using in iterator. So I'm using while of I dot next method to find whether any element is there or not in array. Inside the while loop, is printing system dot out println. Here I'm using I dot next method. I'm using to print. A dot here I'm using system dot inside and I'm using I method to get an element. I'll check the braces one. So now I'm running this program and I'm running so you will get it. Okay, first by using enhanced for loop, next by using half next iterator and displaying the elements present in the array. So this is how we can traverse the elements present in the array. So similarly, there are some more operations. One more operation I would like to show here. Remove operation, which is used to remove an object from the array list. We can use a dot remove, a dot remove, and within the braces you can mention the index. So whichever element you want to index and then I'm going to use index 2. After removing, I'm going to display the element. At index 2, the element present is 30, 30 will be deleted. So now I'm running the program, run my application. And the system will get only 10 and 20, that is image in the array list. Like this, we can apply all the methods available in the array list. This is one example program for array list. Okay. Similarly, we can apply this to any data type. So here integer are taken, and for example, we can use string. We are also using, and then adding the elements, which is giving some code for something. And I'm trying to display it. The same example program I'm taking, I'm using different data types for this array list. So now if I execute this and show, we will get this like this. This is how by using for loop, we are getting all the 3 elements, and by using iterator also, we are getting all the 3 elements, and displaying the apple and banana. Either it can be applied to any other data types, and we can do whatever manipulations we want. Even we can find the size. Then here some statement I am using this statement. File size dot size or I can use so we'll get here size is 6 and 2 elements are available in the so we'll get the size of 6. And we can find whether the element is present in the array list or not. Any other maybe other operations are there. So type here that you can see add all, clone, contains all, equals. You can find whether 2 array lists are equal or not. Remove all these methods you can try. By name itself we can understand. There is a sort method to sort. All these methods are there, we can see. This is one example for array list. Next, linked list. Linked list class is the implementation of the linked list data structure. Previously, we have seen array list class. Now we are going to see about the linked list class. It is basically implementation of linked list backend, which is a linear data structure where the elements are not stored in contiguous locations. Every element is a separate object with a data part as well as address part. We know the linked list representation or linked list implementation. Same thing is reflected here. The elements are linked using pointers and addresses. Every element is also known as node. If you want to create a linked list, it is very easy to access elements available in the linked list. Fast access will be there with the help of this linked list. If you want to create a linked list, you have a predefined linked list class. You have to create an object to this linked list class. as how we have created for array list. Here also we have to use linked list, and we have to specify the data type or integer we have used, and we have created an object and allocated. Here are some linked list methods available, linked list class methods available, like add first method. If you see this add first method, yeah, and within the braces you have to give the element or object to be added. Add first means you are adding the element at the beginning of the list. Add last means you are adding the element at the end of the linked list. And one more thing, you're having get first and get last methods. You can get the element, you can get the object from the linked list. You can get the element, get last element from the linked list class. Okay. And you have two more methods like remove first, remove last. These methods are used to remove the first element from the linked list, and the remove last method is used to remove the remove the last element from the linked list. And apart from this method, there are many other methods like finding the size of the linked list, and so many other methods are also available, which I can show in the demonstration. Now we will see the demonstration of linked list program. Demonstration of the linked list program. Now we will see demonstration on linked list class. Linked list class. So I am going to here. Already we have created package collection file. Same package I am using. I am taking new. Into the same package I am going to create one more class. Now the class name I am giving it example 2, and then I am including that also. I am clicking on the finish. Okay. Now example 2 has a class has been created with main method. Now I am going to create a collection linked list. In linked list, how we can add the elements and how we can do what are the operations available, how to manipulate linked list. That now we will see here. So the class used for linked list is linked list. Linked list class. We create an object. How we have created for an array list. Similarly, we have to create an object to the linked list. Linked list, and we have to give data type and object name. Similarly, I'm taking here as well. New linked list. Linked list. And dimension. Before that, we need to import the package. Total we fill the creating an object to the linked list. I'm going to add the elements to the linked list, have elements to the linked list, all these things. Linked list, fill factor. Now I have given object to the linked list. Now I'm going to add. I'm taking that linked list name is A. So I'm taking A dot add. So here you will get all the methods related to add all, add first, and add last. We'll see one by one. Add method is used to add an element to the linked list, and another method here is add index comma element. So by specifying the index, you can add an element to the particular index. Another one is add all. You can add one linked list to the another linked list, and another one is add all with the help of index. Another two methods you are having is add first and add last. You can add an element at the beginning of the linked list, or you can add an element at the end of the linked list. So first I'm just taking normal method to add the elements to the linked list. Add all, I'm taking some values, integer values, and taking two elements, add all, and all. So now I have added the elements to the linked list. Similarly, here also in linked list, like array list, we can traverse by using the for loop or by using the iterator. Iterator, we can use with the help of iterator, you can traverse all the collection classes you can traverse. Now I'm going to display the elements present in the linked list by using an iterator. I'm going to create a multiple iterator I equals to iterator I equals to, here the linked list name is A. So I'm using A dot A dot iterator mention I'm using. Here you can see iterator and I'm using the value and finding I dot method and I'm going to use next method is get the element. I dot method. So if I run this program, you'll get the output. These are all the elements 40 and 50. Okay. And there are some more methods available in this simple list. You'll see I'm going to add the elements at the beginning of the linked list. For that I'm using dot add first. I'm going to give the some limit, and at the end I'm going to add dot six. Now I'm going to display it by using this. For example, in this system by using the linked list. So now I'm trying to export it. And in this program, we are getting output here. I have added 80 at the beginning of the list and I have added 60 at the end of the list. Similarly, we can remove also the beginning of the element as well as at the end of the element. The beginning element I can remove by using first method, and we can just make and then I'm using method also add remove and then trying to display the linked list. Now if we run this program, we'll get the output like this. First element has been removed with 80 and 60 has been removed by using this two methods. Remove first and remove last. These are all some methods for adding elements. Then we can see a get method, how to get an element by using index print and add get and taking index of. In second position we have I'll take it as index 1. We will get the method available in the index position 1. So run this, you can see this. In the Java application, you can see 0 and 1 position, that is 50. Okay. I'm going to set the element. So set it. Is new dot and set method and taking the second index setting the element. We can be inserted. This to take null value and duplicate values also. Means array list as well as linked list state. Array list as well as linked list contain duplicate values as well as null values. So I'm setting the second index 100. So let us see after executing this program. In the second position, A dot method is the first contact index one and the minimum contact and the index and something that once something that you will see at first position, you will see at the index one null value will be inserted at the index one. Some other value will be inserted. Like that you can set the values to the linked list. You can set the value to the linked list. Even you can find the size, you can rename all these things can go. Index setting them, or you can rename index to 0 and run this code. So this will be deleted and we will get only 100 here. So this is one demonstration program in linked list program. And you can where dot if you do, you can just control all this method. If you click on that, you can copy clone method is used to copy to make a copy of the linked list content. You can find whether the particular element is available in the linked list or not. Contains all, you can check all the elements present in the linked list or not. Like that, similarly, is empty, you can check for the empty. All the methods, if you click on that particular method, you can find explanation here and you can use this in your collection program. And this is very effective. Linked list is better in manipulation when compared to array list. But both linked list as well as array list are not synchronized. They are not thread safe. Then similarly, if you come here linked list, if you want to use some other data type also, like string or float or wrapper class, only you have to use character. Character is the wrapper class. Can here I have to add character and character here. And this deleting all these things and trying to display it. Similarly, deleting. So just added characters and running the program. And it's trying to display it. You can see the characters here displayed. Similarly, you can work with any other data types also. So now we have seen an example program for linked list class, which is available in the list interface. So, so far we have seen only two classes. One is array list and one is linked list classes which belongs to list interface. Maybe next video we will see the vector as well as star classes which belongs to the list interface. Thank you. These are the references I have taken for preparing this PPT, mainly Java T point and Greeks for Greeks, all these things. Thank you.